Oh, class. So in Module 1, we started with taking a 5-volt voltage supply DC, applying it to a series parallel circuit, starting into R1. R1 is then a 1.5 k ohm resistor that it branches out to two branches. One branch is just R2, which is a 6.8 k ohm resistor, and the other branch is R4, 5, and 6, which is 1 k ohm, a 4.7 k ohm, and a 2.2 k ohm resistor in order. And then finally it goes back into series into R3, which is a 1 k ohm resistor, before returning to the voltage supply. Starting with our breadboard, we start with a R1 who's in series with the circuit, which is a 1.5 k ohm resistor. Next, down here, we have two parallel branches, one here and one over here. The first one has R2, which is 6.8 k ohm resistor. And these three resistors, which are in series with each other, are the second branch. The first being R4, which is 1 k ohm resistor, the second being R5, which is a 4.7 k ohm resistor, and the third being R6, which is 2.2 k ohm resistor, and then ending back into series to the final resistor, which is R3, which is a 1 k ohm resistor. After we set up our circuit, we'll attach our DC plus voltage from the analog Discovery 3 to this bus, and then we'll attach this jumper from here, from the bus, over to the beginning of R1. Next, we'll put the return or ground onto this bus on the other side of this, and then jumper this portion to the end of R2, which is the last part of the series portion of the circuit. After that, I connected channel 1 to the positive side of the bus, and then the ground of the bus, to verify that I was getting my 5 volts, as we see. Next, we moved our channel 1 to the top and bottom of the parallel branches to verify the voltage drops for both branches, so that we'll be able to figure out the branch currents. As seen. Next, I moved channel 1 to either side of R2 to verify our total current, since current in here and current out here should be the sum total of these two currents here. Finally, for good measure, I recorded the voltage drop across this single resistor in this branch, so that I can make sure that the current is the same, and then I can kind of figure out what the voltage drop on this one is as well. We then find our currents. First, we'll find IRT by dividing the voltage by the total resistance in the circuit, and it results in 0.812 milliamps. Finding the current through the branch of R2, we will then take our VEQ, which is our voltage equivalency on both branches, which will be IRT times REQ, divided by R2, which is equal to 0.467 milliamps. And then the other branch of resistors 4, 5, and 6 will be VEQ divided by the sum total of R4 plus R5 plus R6, which is equal to 0.376 milliamps.